Alright, to further our journey to be able to get to where we can solve equations that involve logarithms, we need to first learn some properties of logarithms that we can use to either combine or separate logarithmic terms. So the first one that we're going to look at is the product property of logarithms. And it says if I have log base b of something m times n, that I can rewrite that as log base b of the first thing plus log base b of the second thing. So you've probably heard me say before that in math there are some general themes and some things that tend to run together. So it's going to happen here too. So multiplication and addition are going to be together. Division and subtraction are going to be together like they have in a lot of other things that we've done. So when we have a product, one thing times another, we're going to rewrite it as a sum. Now the property works in both directions. So the second part, if you notice, it's the first one that we just talked about. All I did was pick it up and flip it over. So if we're given a sum, we can also write it as a product. So it works in both directions. The second one is the quotient property. So if we have log base b of m divided by n, then we can rewrite that as log base b of m minus log base b of n. And of course the property also works in the opposite direction. If we're given a subtraction, we can combine it as a quotient. And the last one is the power property of logarithms. It says if we have log base bm raised to the p, basically what's happening is this p just comes down to the front, and that's all that happened here. Now I have p times log base b of m. And that one also works in reverse. If we're given p times log base b of m, then we can write it as a power. Alright, so let's look at some problems. Now notice these are just expressions. So all we're going to be doing is rewriting and simplifying if possible. And please note for each one of these, what was important to the rule is we always had the same base, right? So if we're dealing with logarithms that have different bases, there's nothing that we can do to combine those, okay? So if I look at number 1, I have log base x of 3 plus log base x of 5. So they do have the same base x. And this one is given as a sum. So that means we're going to use property 1 and rewrite it as a product. So when we rewrite it, if it's given as a sum, then basically we're going to be putting them back together as a product. So we will need the log base x that they share. And then it's going to become like 3 is my m and 5 is my n, right? So this is going to be 3 times 5. And then what I mean by simplify is we know that 3 times 5 is 15. So the answer to this is just log base x 15. Okay? And number 2 works a whole lot like that one. It's still going to be property 1 because it's given as a sum. So we're going to rewrite it as a product. So we're going to keep the log base 9. And we're going to rewrite the m is 5 times n is x. And then we can just do one more step and say that's 5x. Then the third one, this time we have a subtraction. So now we're going to use property 2. This one is going to become a division. So again, we're going to keep our common log base 4. And we're going to rewrite this as 21 divided by 7. And then, of course, 21 is divisible by 7, so we can simplify that and say it's log base 4 of 3. All right, for number 4, this time you see I have a number being multiplied times the logarithm. So this is that property 3. So what we're going to do for this is we'll have log base 5 of x, but that 2 is now going to become the power of x. So it's log base 5 of x squared. All right, for number 5, we're going to go the other way, right? This one is property 1, but it's given as a product. So we're going to rewrite it as a sum. So there's a lot of different ways you can approach this. When I know I'm going to be rewriting it into two things like a sum, a lot of times I'll go ahead and write log base 8 plus log base 8 because I know that both pieces are going to have that, right? And then my m and n is a 3 and a 5. And that's all we're doing is just rewriting, okay? So number 6, that one's going back to property 3 again because I have a power. So what property 3 tells me is if there is an exponent, then I just bring that down to the front 3 times log base a of x, which of course is just 3 log a of x. Alright, then number 7, I'm given a quotient or a division. So this is property 2. We're going to rewrite it as a subtraction. And again, you don't have to use my method, obviously. But I like to rewrite for myself that I know both pieces are going to have log base 3 and it's a subtraction. And then I know m is the 5 and n is the 2. Now, number 8, this one is a little trickier than the ones we've been looking at so far. You see that cube root of x. Well, that's not a product or a quotient, and in its current form, it's not a power. But if you remember, we learned previously that we can rewrite, let me change colors because this isn't part of the problem. The cube root of x is the same thing as x to the 1/3 because that's a power of 1 and an exponent of 3. So remember we did exponent and root. So the exponent is 1 and the power is 3. So I'm going to write this as log base 7x to the 3rd. And now this is property 3. So that allows me to bring that exponent or power down. So I have 1/3 times log base 7 of x. All right, then number 9, I'm given a sum. So we're going to use property 1 and we're going to change it to a product. So we'll have log base 3. And then we're going to multiply x times x plus 5. And of course we're going to need to clean that up. So if I distribute, I get x squared plus 5x. I put that one in a parenthesis because it's an expression, and we are taking log base 3 of that entire thing, okay? All right, let's look at a few more of these. So the ones back here are going to start combining some of the properties together. So we're going to need to do more than one in these problems. So I see that I have a sum, and I also see that I have this 2 on the outside. So I'm going to do property 3 first. So I can rewrite this second one as log base 3 of x squared. And now that we have that in form, I can use property 1 to combine these as a product. So we'll have log base 3 of 5 times x squared. And of course, that's just log base 3 of 5x squared. All right, then number 11. This one, I see that I have the base and this number is the same. So for this one, we don't have to do a lot of work. All we have to do is say that this one equals 3. You remember that property we learned that said if this base and number are exactly the same thing, they just cancel and I bring down the power. All right, number 12, I have a division. So that's property 2. And I have a power. So that's property 3. All right, so I'm going to separate this into a subtraction. So it's log base 3, log base 3. This one is x. This one is y cubed. And then we use property 3. That'll let me bring that 3 down to the front, and I get log base 3 of y. All right, one more. For this one, it is a subtraction, so we're going to use property 2 and rewrite it as a division. So it's log base 5 of x squared minus 1 over x minus 1. And then for this one, I can simplify because my numerator is a difference of squares, right? It's kind of weird how this material brings in so much material that we looked at before, right? You thought it was over and here it is again, right? So remember, difference of squares is just x minus 1, x plus 1. So if I put that in over here, we know that those are the same, so they can cancel. So this just becomes log base 5 of x plus 1. And again, I use that parenthesis there because it's an expression. And we are doing log base 5 of that entire expression.